Hi, welcome to Woods Creek Workshop. My name is Yuchel. It's another beautiful rainy Friday here in the Pacific Northwest. Good thing I enjoy the rain because otherwise you'd go crazy. Anyway, the spring is here. Trees are, I was going to say trees are blooming, but I guess trees still bloom. Flowers are blooming, leaves are coming up, and it's an exciting part of the year. And another exciting for me is that I received a replacement spindle for my milling machine. I purchased a new, brand new milling machine from a dealer in the United States. They have a good reputation. The milling machine is all made in Taiwan, and has really good specification, and overall I'm very happy with the mill, and I received it end of October. I've searched high and low for used American mill for a few years, and you hear the stories on the internet about how they found this mill never been touched in a barn they bought for $200. Well, although those units do exist out there, it's hard to find one here in the Pacific Northwest. Anyway, so I really like the mill, but the problem is the spindle had a too much run out. The seller, the company lists their specification on their website, and it stated plus and minus 1 thou. So that would be 2 thou. Plus minus 1/10 of a thou. So that would be total run out of 2/10, 0.0002 inches. And shortly after I received my mill in October, I was afraid, but I checked out the spindle with the test indicator. You know how it is. They say ignorance is bliss, but I just had to find out for myself what I got. And unfortunately, it turned out to be 8/10 of a thousand. That is 4 times worse than what the company has stated as their maximum tolerance. Now, I know some guys will say, some of you will say, my mill has a 1 thou, 2 thou, run out, but it's not the machine, it's the user. Although I wholeheartedly agree that a good operator can work around all the shortcomings of the machine, I just feel there's no reason for me to accept something that does not meet the seller's stated specification right out of the box, right? Just like a car, when we shop, we look for all the things that they say it can do, but we take it with a grain of salt, and we check things out. And it's like I'm a Chevy guy, so buy a Corvette. It says, oh, it'll go 0 to 60 in 4 seconds, and you find out after you buy it that it takes 6 seconds, 7 seconds to get there. Although it's plenty faster than a lot of other cars, you're not going to be happy because that's not what was promised. Anyway, the company was delightful to deal with once they confirmed and agreed with me that my inspection methods were appropriate. They contacted the factory, and that process took a little long. Anyway, so here's a new spindle. But instead of sending just the new spindle, as you can see, they sent a quill with it, completely installed. And based on some slight marks on some areas, I think they may have pulled this out of a machine, I don't know. But regardless, let me zoom in and show you some of the things I did on this. So after speaking with the owner of the company a few times, it was agreed that I should not have to swap out the quill, and just simply swap out the spindle alone. It will take a lot less time to begin with, and we just didn't think it was necessary. So that means I'm going to have to take the spindle out of the quill and all that, which I'm going to share with you. But before I even did all that, I lightly set the whole assembly on my cart vise of the mill table. You do not want to clamp it, you don't want to distort anything, but just snug it up just enough that you don't have the movement, rocking movement. And I figured that before I go through all the work of swapping out spindles, that I wanted to ensure that the new replacement is as good as it should be. So like I said, I put this quill on in the vise and took a 10th indicator, and I swept various locations of the spindle taper here while turning the spindle by hand. And everywhere that I measured, it came out at 2/10 of an inch max, total runout, which is exactly at the limit of the company's stated specification. So this meets their spec as it stands. Now my expectation is that the process of taking it out of this quill, reinstalling it in the quill that's already currently on the machine, that process does not alter the runout. That is my expectation. I've been bitten many times in the past in life. That's Murphy's Law, I guess. So I would not be surprised if that does not happen. But that is the plan, and that is the expectation, and that is what the company also expects. So hopefully I can finally put this spindle runout issue to bed. There are a number of toolings that I wanted to finish making and arbors to make for the mill that I've been holding off until I got a new spindle that's within the spec. So this is a big deal. I waited a long time for this. So I'll show you, I'll share with you what I'm doing. First thing I'm going to do is remove this set screw right here. That keeps the nose ring from backing out. It's a metric 2.5 millimeter. It's not in there real tight. In fact, if it's on there tight, you'll have some issues with deformation of the quill, so that it may not retract and return on its own when you're moving the handle up and down. Now, this nose ring has 2 holes, and you're supposed to use a spanner wrench to undo that. Now, I think Bridgeport was right-handed, but this is left-handed. I believe most of the imports are left-handed. So what I found out is that they're really not on there tight. Again, they don't want to affect the bearing preload or whatever, So I did not need spanner wrench for this. The one on the machine, I don't know, we'll see if it's needed. Okay. Now it's a little easier. Now the spindle just pushes out of the quill. If this was installed in the machine, you would tap the end of the spindle with brass, and a hammer to drive the spindle out of it, and it'll come out with the bearings and spacers and all that. But obviously I don't have it on the machine so to hold it. So I'm just gonna lay it on this side and see if I can get it to loosen up a bit. Oh, it's coming out pretty easy. Oh, by the way, see pieces of tape on the nose of the spindle? I marked it so that while I am turning, and when I was taking the measurements with the test indicator, I was getting the runout. And I videoed that, so once I reinstall it on a new machine, as I test the runout on it, I can compare to what it was before this whole process. There you go, it came out. I'm going to put the nose back. I made a mark where the nose goes, just so I don't damage the thread with the set screw anywhere, so may get it in the same spot. This is going to be a spare, but in case I ever need it in the future, I don't want to damage it. Alright, let's take a quick look. Big bearing. There's a bearing on top. And there's a set screw that a lot of people remove. That's to keep your arbor from spinning. I know a lot of people hate that, so they take it out. But I like it on, so I'm gonna leave it on. Alright, we don't have to mess with the preload or anything. There's a nut and a washer, retaining washer that clips onto that. So I guess now we need to go to the machine and take out the one that's there. First thing we're going to do is remove the set screw. Put that somewhere safe. I'm going to wipe some oil off of that nose ring. You'll notice there are pieces of tape on this spindle with the locations marked as well. That's what I was using to keep track of where the runouts were happening. Now, I don't have spanner wrench that'll fit these holes. So I'm hoping again that this one is not on there tight. If they are on tight, I'm gonna have to either make something or figure something else out. So, and this is left hand nut. Well, that's not working. That one's in there tight. Ah, there we go. I cleaned the ring a little bit with acetone to get the oil off of it, so the strap wrench doesn't slip. Now I'm supposed to pound on the spindle from the top, and if I had help, somebody would be here catching it, but I don't have anybody right now to help me. So I'm gonna see if I can use the table and the vise. I don't want the spindle to drop and hit the table or vise when it finally releases. So I got about 3/4 of an inch there. I'm gonna use an aluminum bar. It's not really in there very tight, which is, I guess, good. Ta-da! There it is. Okay, it's time to fit the new one. Grease the spline, grease the bearings. Let's see here. There's a stop right there. Won't go in any further. Time for the nose cone. Now I put a mark right here with a magic marker, Sharpie, so that it lines up with the set screw in the back. You can see indentation on the threading where the set screw was, so I do want to get it back to where that was. It has a little bit to go. What would you do without Amazon? So I could not get this collar, nose ring, I should say, on there tight enough. So I called around all the automotive shops around town, and believe it or not, nobody had one of these. And I'm pretty sure that a lot of cars repairs will need one of these. Anyway, so I had it shipped overnight from Amazon Prime for no free shipping. So I think it was like $13, I think it was. Now put the set screw in. You want that set screw in there just snug enough to keep that nose ring from rotating. What I've noticed is that if you tighten that too much, the quill won't retract all the way up on its own. That's good. So I'm gonna reposition the camera and let's take a reading to make sure that we're still within the spec. Okay, so I have the 10th indicator, the tip about 1/8 of an inch up from the edge of the spindle. I'm gonna slowly turn by hand and let's see what we get. Looks like about 1/10 and a half. Just shy of 2/10. So I'm gonna back it up, and I want to move up a little further up on the taper. Sneak it back up. All right. Camera's in the way, but looks like maybe 1/10. So that is pretty good, but that's without the spindle warmed up. Remember, this is a brand new spindle, brand new set of bearings. So I'm gonna turn the mill motor on, and I'm gonna, at higher RPM. I'm gonna let it run for a while, just let the bearings settle in, and then we'll take another measurement. Okay, so I let the spindle run for about 20 minutes. Started around 600 RPM, and then 1400, and at the higher end. Now let's see let's see if anything changed. So again, we're reading about 1/8 of an inch up from the edge. It looks like just over 1/10. Let me back this out and we'll go up a little more. Alright. Put some preload on the indicator. About a 1/10 and a half, shy of 2/10. That's good. Okay, so I'm very happy with the replacement spindle. It seems to be running a lot smoother. About 1/8 down to 1.5 it's definitely less than 2/10. So I'm happy with that. It's within the spec, and the swap went relatively, simple, quick. The actual work didn't take very long. Fortunately, Amazon, I had this wrench on next day free delivery through Prime, so I had to wait, just overnight to get it done. But I'm gonna keep an eye on that spindle, take some measurements once in a while, make sure that with the new set of bearings that it's breaking in properly and all that. But I'm very happy with it, and I think just like anyone else at the beginning, I was contemplating whether to even do anything about it. And it's easy to say, it's less than 1,000. Just I can work around it. But the fact of the matter is, I really didn't feel that I should have to, because there was an agreement, right? The manufacturer said it's going to be X, and I bought it, and I want X. So the whole interaction went smoothly. I don't have any complaints about that. They took care of it, and the work was pretty simple and easy. So I'm glad that I decided I didn't just accept it as is. At least back in my mind that I did the right thing, and now I can't blame the machine for anything. It's just me, all of me. So anyway, I wanted to share with you that little swap in case you find it useful or entertaining. So I'd appreciate it if you enjoyed it. Please subscribe and like. And if you have any questions, comment or email, and I'll get back to you. And I appreciate you spending time with me. Thank you.